All right, we are on to our third unit, which is electricity. And this unit is going to be sort of split into two. We're going to talk about static electricity to start, and then we're going to look at current electricity. And it was intentional that we learned about chemistry first because electricity involves charges, and we've learned about charges in chemistry. So remember or recall that atoms are composed of protons. They have a positive charge. Remember, they're in the nucleus, the center of the atom. Atoms have neutrons, which are neutral or have no charge. They are also in the nucleus. And then they've got little tiny electrons that are negatively charged that are found outside the nucleus in shells. Okay, so that's important to remember. Everyday objects are made up of billions and billions of atoms. We're going to be looking at some pictures in this unit and we're going to simplify them big time. And remember, it's only electrons that can move, right? Protons are locked in the center of the atom in the nucleus, surrounded by layers of electrons. So it makes sense that it's only the particles, the electrons, that are on the outside that are free to move. Okay, and when electrons, which are negatively charged, do move, it results in a charge, right? If the thing receiving the electron will get a negative charge, and the object losing the electron will end up with a positive charge. Oh, and we do have a Van de Graaff generator at school, which is one of those devices that will make your hair stand up. All right, most objects start off neutral, meaning they've got the same number of protons as they do electrons. Okay, so we're in our electricity unit, not chemistry, so we're not worried about showing the proper structure of atoms. We're just really focusing on the idea of the number of charges. Okay, so a much more simplified drawing. In this square object, whatever that happens to be, you can see there are 5 positive charges and 5 negative charges. So 5 positive, 5 negative, they cancel out. There's no overall charge in this particular object. All right, a neutral object can get a charge though, and there's one of two ways that it can get a charge. It can get a positive charge by losing electrons. Okay, so now our object has 5 positive charges, but only 3 negative charges. Okay, we've lost, in this case, 2 electrons. Okay, leaving it with a positive charge. The other option is it might get a negative charge. Okay, and it would do that by gaining electrons. So look at this picture. We've got 5 positive charges, but it has gained 2 negative charges. So there's an excess of negative charges. Static electricity is the imbalance of electric charge on the surface of an object. Okay, there's a really important law in electricity, static electricity, and it's called the law of electric charges. Okay, and it states, you've probably heard it before, but maybe not in the context of science. So like charges repel. So if we've got 2 of the same charge, whether they are both positive or both negative, they're going to want to move away from one another. Okay, much like magnets with the same poles want to move away. You can't force them together. So that's one half of the law, like charges repel. The other one, and you've probably heard this, maybe more in terms of personalities. Sometimes you hear people say opposites attract. Well, we mean here opposite charges attract. So here's a positive, here's a negative. They want to move together. Okay, that is really the law right here, but here's just an extra thing we should know. Charged and neutral objects will attract. Okay, so the green circle here represents a neutral object. It's not positive, it's not negative, it's neutral. It will be attracted to either a positive object or a negative object. Okay, So why is that? Why are neutral objects attracted to charged objects? Well, let's take a look. So I've got two objects here. I've labeled them. I shouldn't have to though, because you can see the charges inside, right? So that will be enough to tell us that the neutral object is in fact neutral, because it's got the same number of positives as it does negatives. The negatively charged rod, you can see, has a whole bunch of negatives. Okay, so when I bring these two objects together, so they're not touching, look what happens. The negative charges that were in the neutral object are repelled by this negative charge, because like charges repel. So they're trying to get away from this negative charge here, as far away as possible. Well, the furthest place they can go is this side of the neutral object. Okay, so remember, like in the chemistry unit, we talked about how electrons can move. Protons cannot. So the positive charges in this neutral object are in the exact same position as they were in the first slide, or the slide right before this. It's just the electrons that have shifted. Okay? Again, only the electrons can move or shift. And so this explains why there's an attraction here. The negatives have moved away. So now this side of the neutral object has a positive charge. This side of the neutral object has a negative charge. Well, opposite charges attract. This is negative, nothing has changed here. This side is positive, and so now these two objects want to move together. This is called an induced charge separation. Okay, this negatively charged rod has induced, or how else could we say that? Brought on, I guess, a charge separation. It has separated the negatives within this neutral object from the positives. Okay, now this is just temporary because, sorry, let me just, oh, sorry. We'll get there in one sec. So again, just as I was saying, the left side of the neutral object gets a negative charge, the right side gets a positive charge. It's now attracted to the rod, but when I move them apart, everything goes back to normal, right? The negatives within here have redistributed themselves evenly. Okay, they only shifted when they were influenced by this negative charge. That's why it's temporary. Okay, they didn't stay over on the left side. Once the charged object was removed, they returned to their original position. Okay, well, the same thing can happen with a positively charged object, or a similar thing, I should say, can happen. Not exactly the same. So here's my neutral object again labeled. This time I've got a positively charged object. Okay, when I bring the positively charged object near, but not touching the neutral object, look what impact it has on the electrons in the neutral object. Opposite charges attract. So the negatives within the neutral object are attracted towards this great big positive charge. So they move as close as they can to it. Remember, only the electrons are moving. Okay? This is an induced charge separation. Okay, this is called charging by induction. So again, that leaves the neutral object with a negative side and a positive side, all because the electrons have shifted their position. Okay? The location of where the electrons move is all influenced by what charge this object is. When it was negative, they moved away, they were repelled. When it's positive, they move towards because they're attracted. Now, when I separate them, when I take the charged object away, look what happens. The neutral object returns to its original state. The electrons are evenly distributed. It is neutral. So this was just temporary. Bringing it near bringing the charged object near the neutral object was just a temporary thing. Okay? All right, so that is some of the basics of static electricity.